In this video lecture, I will explain logical equivalence. So what is logical equivalence? Any two propositions U and V are said to be logically equivalent if they have the same truth value. So if I have two compound propositions U and V, so U and V are said to be logically equivalent if they have same truth values, and it is represented by this symbol. Okay, so if I have to check the logical equivalence, we'll be drawing the truth table for both the compound proposition U and V, and if we get the same truth value, then we'll say that it is logically equivalent. So first way of checking the logical equivalence is just drawing the truth table and getting the same value. Another way of checking the logical equivalence is if I say any two compound proposition U and V are logically equivalent, that means U biconditional V, this is the symbol used to represent the biconditional, U biconditional V should be a tautology. Then also if U biconditional V is a tautology, that means U is logically equivalent to V. Okay. So now let's take one example. If I have to check this compound proposition P implies Q is logically equivalent to negation of P or Q. So how we will check? We will draw the truth table. So P implies Q, we know, except if I have two proposition PQ, so my input will be 0 0 0 1 1 0 and 1 1. So except 1 0 pair, for all other input it will be true. So 0 0 it will be 1, 0 1 also it will be 1, 1 0 it will be 0, and 1 1 it will be 1. And then this is the truth value for P implies Q. Okay, so these are the values, and then we have to draw the truth table for negation of P or Q also. So first we will write for negation of P. So 0 it will be 1, 0 it will be 1, 1 it will be 0, for input 1 it will be 0, and then we have to take OR. So OR means one of the input should be true, then it will be true. So 0 1 it will be 1, 1 1 it will be 1, 0 0 it will be 0. When both the inputs are false, definitely the output will also be false, and 1 0 one of the input is 1, so it will be 1. So we can see here both P implies Q and negation of P or Q, we get the same truth value 1 1 1 1 0 1 1 1 0 1. So first way of telling the logical equivalence, we'll say okay, these two compound propositions have same truth value, so they are logically equivalent. Or what we can say, negation of P implies Q biconditional P implies Q. Okay, and that should be a tautology. So if I take biconditional, so biconditional we know when both the inputs are same it will be true. So 1 1 it will be 1, 1 1 again it will be 1, 0 0 it will be 1, 1 1 again it will be 1. So when both the inputs are, so I should take the biconditional of these two, and both the inputs are same, it will be 1. So all the values are 1. So definitely this is tautology. So then also, okay, so that way also we can say that these compound proposition P implies Q or negation of P or Q, they are logically equivalent. So we can draw the truth table, or we can take biconditional of both the compound proposition, and it should be a tautology. Okay, so let's take few more examples. So here P implies Q is logically equivalent to negation of P or Q, just now we have seen. Similarly, if I say P biconditional Q is logically equivalent to P implies Q and Q implies P. So let's verify this. If I have two compound proposition P and Q, so input will be 0 0 0 1 1 0 and 1 1. Okay, and then P, second one we are doing, so P implies Q. So P implies Q means except 1 0, for all other input it will be 1. So 1 1 0 1. Okay, and then Q implies P. So always remember P implies Q and Q implies P are not same, because if I say P implies Q, I need to consider P first and then Q. If I say Q implies P, I need to consider Q first and then P, because if I say P implies Q, my input will be 0 0. Or for example, if I say 0 1, P implies Q 0 1 will give me 1, but Q implies P, it will be 1 0, then it will be false. So both are not same. Okay, so Q implies P means I should see this way. So 0 0 will be 1, 1 0 pair it will be 0, 0 1 again it will be 1, 1 1 it will be 1, and we should take AND of these two. So P implies Q and Q implies P. So when I take AND, both the input is 1, so it will be 1. One of the input is false, it will be false. Here also it is one of the input is false, it is false. Both the inputs are 1, so it will be 1. So this is nothing but P by conditional Q, because that's what P by conditional Q is. What P by conditional Q is, when both the inputs are same it will be true, and when inputs are different it will be false. So 1 0 0 1, here also 1 0 0 1. So that's why they are logically equivalent. These also can be checked. This is exclusive, or P exclusive or is logically equivalent to P or Q and negation of P and Q, or P or Q and negation of P or negation of Q. So all these can be verified using truth table. So what we have to do, if I have to see the logical equivalence of these two, I need to draw the truth table for this, we need to draw the truth table for this, and both should be same. And if I have to check the same way, we can draw the truth table for this also, and all these, this one, the truth value for this compound proposition, the truth value of this compound proposition, and the truth value of this compound proposition will be same. So that's how we will say that they are logically equivalent. Okay, same way this also, the truth value of this one, truth value of this one, and the truth value of this one will be same. See, both the questions 4 and 5 are same. For to show the exclusive or, we can use either this symbol or we can use this symbol. Okay, so let's take this one, and we'll just one I will show, the other one you can verify. So P by conditional Q. Okay, so I have P Q, and this is 0 0 0 1 1 0 and 1 1, and P exclusive or Q will be this will be 0 0 1 1, because when inputs are same it will be false, inputs are different it will be 1. Okay, so P or Q, so P or Q will be what, one of the input is true, so it will be true, so it will be false 1 1 1, and then negation of P and Q. So first we'll write P and Q. So P and Q, it will be 0 0 0 1, and then we'll take negation of P and Q. So it will be 1 1 1 and 0, and then this one and this one we need to take AND again. Okay, so it will be 0 1 1 and 0. Okay, so you can see here this is the final answer, and here this one, both are same, right? 0 0 1 1 1 1 0 0. Same way this one also we can verify. If I say P or Q is this one, negation of P or negation of Q. So negation of P, if I say negation of P, it will be 1 1 0 0. Negation of Q, it will be 1 0 1 0, and then negation of P or negation of Q, it will be 1 1 will be 1, this will be 1 1 and 0, and then P or Q, this value and this value I need to take AND. So if I take AND, 0 1 will be 0, and then 1 1 will be 1, and then 1 1 will be 1, and 1 0 will be 0. So even this also is same. So you can see these three are logically equivalent. So that's how you can check the logical equivalence of any two compound proposition. The other method, what you can do, you can take the biconditional of these two and prove that it is tautology. Same way you can take the biconditional of these two and show that it is tautology. So definitely biconditional you will get true value only, because biconditional it says when the inputs are same it will be true. So 0 0 it will be same, so true. 1 1 also it will be same, so true. 1 1 again it is same, so true. 0 0 again same, so it is true, so it will be definitely tautology. So hope you have understood the concept of logical equivalence. Thank you for watching.